A massive beast cuts through the water at dawn. The sail on its back sways gently in the morning breeze. No roar, no splash, just a soft ripple. Then suddenly, a lightning-fast strike, a giant fish flung into the air. That was Spinosaurus, a name that stirs both excitement and debate in the paleontology world. One of the strangest and most puzzling dinosaurs ever discovered. Spinosaurus, meaning spine lizard, lived around 99 to 93 million years ago during the late Cretaceous period. It ruled the sprawling river systems of what is now North Africa, a land once filled with crocodile-like reptiles, armored turtles, and monstrous fish like Mausonia. In that world, Spinosaurus reigned not because of brute strength, but because it was unlike anything else. The first fossils of Spinosaurus were uncovered in 1912 from the Bahariya Formation in Egypt by fossil collector Richard Markgraf. In 1915, German paleontologist Ernst Stromer officially described the species, but in a cruel twist of fate, the original specimen containing parts of the skull vertebrae and spines was destroyed in a British bombing raid in 1944 during World War II. Since then, Spinosaurus became a mystery that haunted paleontology for nearly a century. All that remained were Stromer's sketches and notes. For a long time, no one knew what this creature really looked like. Some even speculated it was a chimera, a mistaken fusion of parts from several different species. But in the early 21st century, new fossil discoveries in Morocco, Tunisia, and Algeria began to shed light on the true identity of this predator. Slowly, piece by piece, the image of Spinosaurus returned, and it shocked everyone. Unlike classic meat-eating dinosaurs like T-Rex or Giganotosaurus Spinosaurus, did not have a robust skull or serrated teeth for slicing flesh. Instead, it had a long, narrow snout like a crocodile with smooth, conical teeth spaced apart, perfect for gripping slippery prey. Its nostrils weren't at the front of the snout, but farther back, allowing it to breathe, while keeping most of its head submerged, just like a crocodile lying in wait. But what truly made Spinosaurus iconic were its giant neural spines rising from its back, forming a massive sail stretching from its shoulders to its hips. Some of these spines reached up to 65 meters tall, as high as a grown human. It gave Spinosaurus a silhouette. No other dinosaur had a predator with a sail on its back. So, what was the sail for? The first theory is thermoregulation. In the harsh climate of ancient North Africa, hot by day, cold by night, a structure like this could function as a natural heat panel. In the morning, Spinosaurus could turn its sail toward the sun to warm its blood. At midday, it might use it to cool down by catching the wind. Another theory suggests the sail was used as a display, much like a peacock's tail, to attract mates. A large, colorful sail might have been a signal of strength age or genetic health. Then there's the bold idea proposed by Jack Bowman Bailey in '97 that the sail was actually a fat-storing hump like those found on camels or bison. Such a hump would help Spinosaurus store energy during lean times, as well as insulate and protect vital organs from heat. And perhaps all of these theories are true. In nature, structures that serve multiple functions tend to survive longer. The sail may have helped regulate temperature, attract mates, store energy, and even make the dinosaur appear larger and more intimidating to rivals. Spinosaurus is unique in another way. It wasn't just the African T-Rex. It wasn't a recycled version of the classic apex predator. It didn't need a crushing bite. It didn't need to sprint. It was a stealth hunter adapted for ambush, for precision, and for water. And this is only the beginning of the story. Because if Spinosaurus wasn't made to rule the land, maybe, just maybe, it was built to dominate the rivers. Picture this. You're standing beside a vast river in ancient North Africa. The sun blazes overhead, The muddy water ripples gently. Suddenly, there's movement. A dark shape rises, a massive creature with jaws like a crocodile and a sail towering above its back. In an instant, it lunges. Fish scatter. And then, silence. The river is calm again. You've just witnessed the hunt of Spinosaurus, not a typical dinosaur, but a true aquatic predator. While most theropods were designed for life on land, Spinosaurus was a creature of the water. Its entire body was adapted for swimming, stalking, and ambushing prey in rivers and lakes. In fact, it may have spent more time in water than any other dinosaur ever discovered. Let's start with the skull. Long, narrow, and filled with conical, non-serrated teeth, it resembled that of a gharial or crocodile, perfect for snapping up slippery prey like fish. The jaws had deep pits and grooves that likely housed pressure-sensitive receptors, allowing Spinosaurus to detect the tiniest ripples in the water, just like modern crocodiles. Even the placement of its nostrils was unusual. Instead of being located at the front of the snout, they were pushed back toward the eyes. This allowed Spinosaurus to keep most of its head underwater while still breathing, a clear advantage for stealth hunting. Its body was no less specialized. Fossils show that Spinosaurus had unusually short hind limbs for a theropod, and this confused scientists for years. How could such a large predator move efficiently on land with such tiny legs? The answer, it didn't have to. In 2000, a groundbreaking study by Nizar Ibrahim and colleagues revealed that Spinosaurus was likely semi-aquatic, using those short legs and long tail to propel itself through water. Unlike the stiff tails of most theropods, Spinosaurus had a broad, paddle-shaped tail, nearly symmetrical in design, similar to that of a newt or eel. It acted like a rudder and motor, combined, letting the animal maneuver swiftly through water. A later fossil discovery in 2018 further confirmed this. The new tail specimen showed clear signs of muscular vertical movement, suggesting Spinosaurus could generate powerful thrusts underwater, just like an aquatic reptile. Its sail, once believed to be purely decorative or thermoregulatory, may have also had a hydrodynamic function. Some scientists speculate that it helped stabilize the animal during swimming, acting like a keel on a boat. When the dinosaur twisted its body or turned sharply, the sail could have counteracted the torque, keeping it balanced and efficient in pursuit. But it wasn't just about anatomy. Chemical evidence backs this up too. In 2010, a study of oxygen isotopes in Spinosaurus teeth revealed values closer to those of turtles and crocodiles than to land-dwelling dinosaurs. This suggests that Spinosaurus spent most of its life in water, not just near it. That same year, researchers found that Spinosaurus's jaw lacked the structural strength for twist and tear attacks, the kind of motion used by T-Rex or modern crocodiles when dismembering prey. Instead, its jaws were better suited for gripping, puncturing, and swallowing prey whole again, more like a fish-eating predator than a land-based killer. Some paleontologists have compared Spinosaurus to sailfish and thresher sharks, both of which use their tails or fins to stun and corral fish. It's possible Spinosaurus did the same, whipping its tail to scatter prey, then snapping them up with precision. In an ecosystem packed with competition, massive crocodiles, predatory fish, and other theropods, Spinosaurus found success not by outrunning or outfighting, but by outswimming. It became a specialist, a stealth hunter, and perhaps the only true aquatic dinosaur we've ever known. Of course, that doesn't mean it was helpless on land. Spinosaurus could likely still walk, albeit awkwardly, on its short hind legs. It may have dragged itself across riverbanks, lurked in muddy shallows, or rested on sandbars, waiting to strike. But water was its domain. Its world wasn't dry plains or dense forests. It was muddy deltas, swampy floodplains, and vast winding rivers teeming with prey. And in those waters, Spinosaurus was king. No other dinosaur hunted like it. No other dinosaur lived like it. And no other dinosaur challenged our understanding of what a theropod could be, quite like Spinosaurus did. The river is quiet again. Spinosaurus has vanished beneath the surface. But when it comes back onto land, how does it walk? This is the question that has kept paleontologists arguing for decades. For most of history, Spinosaurus was thought to walk like every other large theropod, on two legs upright, tail stretched behind for balance, like a T-Rex. Early reconstructions even showed it towering over other carnivores, its sail slicing the air like a prehistoric flag. But in 2014, a bombshell study by Nizar Ibrahim and colleagues challenged that entire vision. Based on a series of new fossils unearthed in Morocco, the researchers discovered that Spinosaurus's hind legs were much shorter and more slender than expected. So short, in fact, that they seemed incapable of supporting the animal's weight in a fully upright stance. This led Ibrahim's team to propose something radical. Spinosaurus may have walked on all fours when on land. It was a claim that shocked the scientific community. No known theropod dinosaur, a group defined by walking on two legs, had ever been shown to go fully quadrupedal. But the anatomy was strange enough to suggest it might be possible. Spinosaurus's center of mass, they argued, was no longer over the hips as it is in most theropods. Instead, it had shifted forward closer to the torso. This change, combined with the short hind limbs and elongated torso, meant the dinosaur could have used its powerful forelimbs to help support its weight while walking. Suddenly, images of Spinosaurus changed. No longer the proud, upright killer, it now appeared more like a crocodilian monster, low to the ground, moving awkwardly along muddy riverbanks. But not everyone was convinced. John Hutchinson, a specialist in biomechanics, raised concerns about the reconstruction. He warned that the 2010 model was based on bones from different individuals, possibly even different species, and that combining them might distort the true proportions. Scott Hartman, a renowned skeletal illustrator, went further, arguing that the legs had been scaled incorrectly, possibly shortened by as much as 7%, making Spinosaurus appear more hunched than it truly was. On the other hand, Mark Witten, a respected paleo artist and researcher, defended the proportions, claiming they made functional sense for a semi-aquatic lifestyle. He suggested that Spinosaurus's odd shape wasn't an error, it was just evolution doing something new. Then in 2018, a more complete tail fossil came to light, prompting yet another reevaluation. Paleontologist Donald Henderson created a new digital model using this data. His results showed that Spinosaurus's center of mass may have been further back, allowing it to stand and walk on two legs, though its gait would have been slow and awkward. So, which version is true? Was Spinosaurus a biped, a quadruped, or something in between? The answer might lie in how it lived. In water, Spinosaurus needed little support from its legs. Its tail did the heavy lifting. On land, it may have stood on two legs briefly, but relied on its arms to help with movement over short distances, much like modern crocodiles, which are fully aquatic but can haul themselves onto land when needed. And we now know these adaptations started from birth. In 2005, paleontologists described a tiny fossil just 21 millimeters long. It was a claw from a juvenile Spinosaurus belonging to an individual just 1.78 meters long, the smallest specimen ever found. Despite its young age, it already had the hallmark traits of its species: reduced hind limbs, specialized snout, and likely a semi-aquatic way of life. That means Spinosaurus didn't grow into the water. It was born to swim. Its entire body, head, limbs, tail, and possibly even sail, was optimized for life between land and water. It didn't dominate by brute strength like a T-Rex. It didn't rely on pack hunting like a raptor. It carved out a unique ecological niche, standing at the crossroads of two worlds. This perhaps is the greatest legacy of Spinosaurus, not just its size, its sail, or its jaws, but its difference. It broke the rules. It rewrote the blueprint for what a predator could be. And even now, it challenges us to question what we think we know. But how much more remains buried in the sands of the Sahara? Could a single new fossil finally reveal how Spinosaurus truly moved, hunted, and lived? Until then, it remains one of the greatest mysteries in paleontology. If you found Spinosaurus as fascinating as we do, make sure to like, comment, and subscribe to Extinct Legends. Hit the bell so you don't miss the next deep dive into the lost world of prehistoric giants. And let us know below, which dinosaur should we uncover next?